Good evening and welcome to our first live stream of 2026. AQA GCSE Geography, and we're back for season 3 of the live streams. I'm so excited for this one. I hope you can hear me. I hope you can see everything. We're just trying out a bit of new technology. We're trying to upgrade the channel and make it even better than last year. Who's in the chat? Let us know who's here. Say hello. Hit us up. Say give us your names and see who is joining us for tonight's live stream. So excited for this. I might be a little bit rusty. It's over a year ago, or about a year ago, since I did a live stream. So we'll see how we get on. Tonight we're going to look at AQA question 1, natural hazards, and look at the key content for 2026 exam. Hopefully we can get you ready and prepared and feeling confident, ready for that exam on the 13th of May. Yeah, you've come to the right place. I think we're still the only live stream on YouTube, I think. So, yeah, unless I'm mistaken, let me know if there's any other geography live streams out there. I'd love to know. Right, let's see who's in the chat then. Here we go. PK has. Could you do a paper 2? Yeah, definitely. Stay tuned, subscribe, like, all that good stuff. Paper 2 we'll do in about 6 weeks' time. 5 or 6 weeks down the line, we'll look at some paper 2 content. Definitely covered here on the channel. You are more than welcome. Corey, yes, I know you've been asking for live streams, and here they are. Oh, it's going to be an epic one tonight. We've got a new addition as well to our live stream. At the end, there is an interactive Kahoot quiz to see who the best geographer is in the country, ready for this next exam coming up. Oh, Archie's in. Good to see you, Archie. Hello, good to see you. How's the holidays going, guys? What you been up to? Have you visited anywhere yet? Let me know. How the live streams work. If this is your first ever geography live stream, we do like intros for about 5 minutes. Say hello to everybody. We grab our cup of tea, we grab a biscuit and some sweets or anything like that, and we make sure we've got all the things we need for our active live revision, which is, let me just show you what you're going to need tonight for this Monday night session. Where's the other one? That's the one I want. There we go. So, guys, you're going to need, let's just get zoomed into this. For our live streams, you're going to need an array of coloured pencils. It wouldn't be geography without coloured pencils. A drawing pencil, a ruler, highlighter, always have a highlighter, a writing pen, a nice piece of A4, plain A4 paper, or you could use the little mini revision cards. They're quite good. You could use those for your revision. Obviously, it's called cup of tea. There we go. Cup of tea. And always a biscuit as well, just to get you through that revision, give you that little bit of a pep sugar rush when your energy starts to drop a little bit lower. So what we're drinking, have you got any snacks with you as well? Have you got any biscuits with you? What biscuits have you chosen for tonight's revision? Oh, customary to have a little slurp of the tea before we start. Also, yeah, penguin biscuits. Treated myself to a penguin biscuit here. Now, these used to, back in the day, have a little joke on. Let's have a, oh, we have got a joke, guys. We have got a joke officially on the first live stream of the year. So here you go. You can hit us up in the chat, guys. Oh, let me just say hello to Evan. Yeah, if you cannot comment, you need to have a YouTube account that's not private. So if you've got a YouTube account that's not private, you can comment and get involved in tonight's live stream. Right, are you ready for the joke? How do penguins get around? How do penguins get around? Hit us up in the chat if you know the punchline to that probably terrible joke. It will be, I'm sure. Right, we're going to get started in 2 minutes. 2 minutes. If you've joined us, say hello. Frederick, good to see you, Frederick. Thanks for joining us on tonight's live stream. Anybody else? We've got Evan 184. Good to see you, Evan, as well. Thanks for joining tonight's live stream. We've got a series every Monday, a live stream getting you ready for the summer 2026 AQA GCSE Geography. Give yourself that little edge against the others in your year group. Yeah, that's what it's all about. Right, we're just going to go back to full screen just very quickly. The punch joke. The punchline to the joke was, how do penguins get around on a bicycle? Yeah, on a bicycle. Yeah, you get it. Snow, ice. Kind of geographical, to be fair. It's quite good. Yeah, so that's tonight's terrible penguin joke. Right, I think it's time to get started on tonight's revision. And make sure you got your paper ready, your revision cards, your colours, your pens, and we're going to go through question 1, natural hazards, and some content that I think is going to appear this year in your examination. So, are we ready, guys? We're going to switch cameras. Bearing in mind, we have got a quiz at the end, so stay tuned for that. Full-on Kahoot quiz at the end. So get involved in that. All the answers are in this revision. So all the answers are in the revision. If you do the revision, you're going to do absolutely amazing at the quiz at the end, which will be good. Right. Shall we get cracking, guys? Right, here we go. Let's switch the cameras around and get down to some geography revision. If you are watching it live, you can do it live. Obviously, you can watch it on catch up as well, whichever you prefer. Right, here we go then. It's an interactive session, so get involved. I will ask you questions related to the content of tonight's revision, and you can hit us up in the chat, and we'll get a little scoring system going, I think. So we'll see who's in the chat. We've got Corey, we've got Archie. So we'll get a little league table going here. I guess we've got Evan, Fred. Oh, we've got another Fred, Finley the Gamer, G3M. Finn, good to have you in, Finn. Finley, you're in. Right, you're on the scoreboard. We'll keep a going score for the questions that are coming up. Right. Okay, let's go for this then. Right, here we go. Up in the middle, at the top, you have to write quite small to get everything on tonight's revision, but it'll all be on one page. Paper 1, physical geography, my favourite. Absolutely love my physical geography. And this is the 13th of May, which I believe is a Wednesday. Quite like Wednesdays because it's the middle of the week. It's a Wednesday. It's in the morning, guys. So get yourself up and about early. Let's just zoom in there. Yep. And there we go. Get in focus. And the exam itself is the same as all of them now. 1 hour and 30 minutes in length. So that's what we're preparing for. Oh, that's what we're preparing for tonight. So let's go to our must-see content. So I'm going to this top left-hand corner now, as you can see on the camera. Hopefully you got that. I didn't go too fast there. There we go. Here we go, guys. Oh, we've got some. Evan is Callum, by the way. Nice one, Callum. Callum. Ah, yes. Surnames. Yes. Right, Callum. Let's whack you in there. Yep. Good stuff. Callum. And who else we got here? We've got Tay, another good geographer, joining us this evening. We've got some of the top 20 in tonight. I love the top 20 in for our live stream. Okay, here we go. Question 1. Question 1, the first question you'll answer in the summer for geography is natural hazards. It is a complete 33 marks in total. And that should also take you, in terms of time, keep an eye on the time, 35 minutes to complete. So this is the biggest section. It's worth the most marks. There we go. It's worth the most marks. It's 33 minutes. 33 marks, and it's 35 minutes. Keep an eye on the time. The exam should start around about 1 o'clock, and therefore you should be finishing this one at around about 1:35. Just keep an eye on your timings. Right, what must you know every year, but also in particular in 2026? So these are our must know content. This is a double hitter. So it's tonight's live stream and next Monday. Must know content for this section. I've put my pen. Here it is. Here we go. So we have tectonic plates, which we're going to cover in tonight's session. How much do you know about your tectonic plates? There's going to be some questions coming up very shortly on tectonic plates, to which we have 3 different types that we need to be aware of. Number 2 is management of hazards. So management of hazards, a very important topic, one that is not done well in the past by our geographers. Management of earthquakes and management of volcanoes. Right, number 3 is climate change. I reckon this is going to be a big feature of the exam this year. You've got to be an expert in climate change causes and management in particular, I think, is a feature. And last but not least of your little checklist of things, hazard case studies. Always case studies. This, I think, it's more likely to be tectonic hazards. So your earthquakes and volcanic case studies. So we had Haiti and L'Aquila, and which I'm going to cover next week, a tropical storm. Tropical storm, which ours was Typhoon Haiyan. If you're worried about your case studies for this section, tune in next week, set that notification bell, and drop in and join us for the case studies. So today we're going to cover the top 3 there, ready for our exam. We're going to give them a little tick actually, because we are going to cover all those 3 in today's session. Right, I just want to cover, before we start, they often talk about impacts of hazards, social, economic and environmental. So pick this up from the exam board this year. Social impacts. If you ever see the word social in a question, you should think about 2 things in particular. There's many aspects of social, but the 2 key ones are health and education. Health and education. So when you see the word social, think about health impacts, think about education impacts. They're the 2 main ones to get you think started. Then you could think about maybe community, well-being, religion, things like that could come after. Economic. If you see economic in a question, you should think straight away money and jobs. So start to think about money, the cost of things, and jobs, and how jobs have been impacted by whatever you're talking about. You can also talk about things like business, trade, imports, exports, inflation, but the main ones for economics is jobs and money. Right, oh, got a bit excited there, threw the pencil over on the floor. There we go. Right, our last category for geography. These are our 3 kind of dimensions of geography: social, economic and environmental. Really important when you're studying geography. Environmental, we think of wildlife. So think about wildlife and pollution. Yeah, pollution of the air, water, soils, things like that. So there's just a quick reminder of, if you read in the question social or economic or environmental, these are the little subcategories that you should be thinking of when you see those trigger words. We've got another visitor, Sadu. Let's add you to the, thanks for joining us for the live stream tonight. Let's add you to the list. Right, it is question time. Right, let's go on to tectonic plate boundaries. tectonic plate boundaries. Hope you can read my writing, guys. It is not the neatest, but so this one is a biggie every single year. You always need to know your tectonic plate boundaries. What do we mean by tectonic plate boundaries? It's when two or more tectonic plates collide. That's what we mean by our boundaries, where two or more tectonic plates collide. Let's highlight that so it stands out a little bit. That's kind of key, what a plate boundary is. Yep. And we have 3 types of plate boundaries. Here's up in the chat, guys. What are the 3 types of plate boundaries? Spelt correctly, and the winner will get a point on the leaderboard. What are the 3 types of plate boundaries? It is. Answers are coming in. I can feel it. Ooh, constructive, destructive, and conservative. Fred, let's have a look. There we go. Fred has nailed it. He is 1 point on the board. Well done, Fred. That is correct. Constructive, destructive, and conservative. Right, so there's some more questions coming up. We're going to have a little look at conservative. How do plates move at a conservative plate boundary? Hit us up in the chat, guys. Callum, yes, you've also got it correct, but you are not the fastest answer. Unfortunately for you. So we're going to draw a little table now to show the plate boundaries. All right. How do the plates move at a constructive plate boundary? Right, guys, we're going to need a table in this bottom corner now. So here we are. This is the full, let me zoom out a little bit so you can see. The full bottom corner of the paper. And this is a 3-column table all the way down to the bottom. And we're going to have the 3 types of plate boundaries. We're going to have explanation. We're going to have named example and a little diagram as well. So we're going to have in here type of plate boundary, explanation, because that's what it'll say in the exam. It'll say explain this, explain a destructive or a constructive, and then an example, because we're going for those higher marks. So did anybody get the answer? How do plates move? What direction do plates move in at a constructive plate boundary? So we're going to start with our constructive. Here we go. So the first one up is a constructive. Okay, these are the most common types of plate boundaries on Earth. Yeah, this is the one you find most of, constructive. So let's draw a little picture. Or a diagram. Again, in an exam, you could draw an annotated diagram. And the correct answer is the plates move apart. So the plates are moving apart. Let's add a little bit of colour. Here we go. This is the mantle area. Put that in there. Okay, a little bonus point for you guys. A little bonus point. What causes the tectonic plates to move? What causes the tectonic plates to move? Hit us up in the chat. You can get a point for this one. So the plates move apart. The magma rises up the middle. And that forms our volcanic islands. Yeah. What causes the tectonic plates to move? So as you can see, these Callum has put magma. Yeah, kind of right. It is the magma, but it does have a specific name. What is the name of the flows in the upper mantle called? The flows of molten rock in the upper mantle. Okay, we're going to have to go for it now. They're called convection currents. Convection currents. There we go. So convection currents move the plates in opposite directions. The magma rises to the surface. It cools and condenses to form new land. That's why they're called constructive, because these build new land or islands generally. So build new land or islands. Okay, this is a summary of what they do. So here we go. Plates move apart due to the convection currents. Let's put that number 2. The convection currents in the upper mantle or the asthenosphere, which is the upper mantle in the asthenosphere, cause the plates to move in opposite directions. They move apart. As they move apart, the magma from the mantle rises. It then cools, or what we call solidifies, goes into a solid, solidifies to form new crust, new land. They often are found at the depth of oceans to form ocean ridges. So you often get a chain of volcanoes at the bottom of an ocean, which is called an ocean ridge. And generally, these earthquakes and volcanoes are non-violent. Pressure doesn't build up to such an extent where they become very violent. So in the chat, guys, can you name a famous constructive plate boundary? So hit us up in the chat for a point. Who can name a famous constructive plate boundary where plates move apart, forming volcanic islands or ocean ridges? That is a big clue. Whilst I'm waiting, I'll just do a little bit of colouring in. There we go. Right, who's got one? No one's got an example. So the most famous example is the Mid-Atlantic Ridge. So remember, guys, if you can name an example, you have leveled up your answer. And when you level up your answer, we go. Yahoo! Yep. A geography answer without a place is not a leveled up answer. So add a little bit of Mario to your answer. Level it up. Oh, God, things you do. Right, the Mid-Atlantic Ridge is our named example. These plates are the ones that are moving apart at the Mid-Atlantic Ridge. Let's name them. So we've got the Eurasian plate, and the North American plate. So the North American plate and the Eurasian plate are the two that move apart there. And these form volcanic islands in the Atlantic Ocean. Volcanic islands, which is very famous. And the most famous one is Iceland, is on a constructive plate margin. Iceland has a lot of shield volcanoes. These are very flat profile volcanoes called shield volcanoes, very common on Iceland. Right, there we go. Look at that. That would be a model answer. 6 marks possibly on constructive plate boundaries. So really happy with that. Right, let's go on to our destructive one. Okay, so our next one is destructive. In fact, we're just going to highlight these names because these are so important. Constructive, destructive. Let's get them highlighted in green so we can see them. So they stand out really brightly. Okay, a little quick sketch of a destructive boundary. So here is our oceanic plate carrying ocean. And here is our continental plate carrying land. It's our volcano. So let's put our continental plate in. Carries land. Our oceanic plate carries basically oceans and bodies of water. There we go. Often we find a deep ocean trench where we get destructive boundaries. Deep ocean trench. Yeah. Where we get destructive boundaries. We also get volcanic activity. And we get very violent earthquake activity as well. So our destructive ones are very dangerous. Extremely dangerous. They create violent earthquakes, deadly earthquakes, and violent, deadly volcanic eruptions. The reason why they're called destructive is because plates are destroyed as they enter the mantle. Yeah, you see this plate here that's going downwards into the mantle. That is being destroyed. Okay, I'm going to give you another positive point for our quiz. What do we call it when a plate, an oceanic plate, goes below, shifts below, moves below a continental plate? Hit me up in the chat, guys. What do we call it? When an oceanic plate moves below a continental plate, such as the one in the diagram. Okay. Let's rule that off there a minute. Okay, let's get our explanation in as well. See who's going to come up with the answer. So at a destructive boundary, the plates collide. They move together. So they collide with each other as they put the arrows on there. There you go. They move together. They collide. Oceanic plate is denser or heavier. So is denser slash, let's put heavier as well, just so you can remember. The oceanic plate will, this is the word I'm looking for. Anybody hit us up in the chat there? No. At the moment, Fred is winning with 1 point. It's an easy crowd tonight. The answer is subduction. You cannot talk about a destructive boundary without mentioning subduction. This is where the oceanic plate subducts below. So it moves underneath the continental plate. It subducts. It goes below. Below. Okay, as this plate slides past the other one, there's a lot of friction and pressure builds up between the plates. That's really key, guys. Friction and pressure build up between the tectonic plates. And we get here violent earthquakes. As that pressure is released, we get violent earthquakes as the pressure is kind of released. We also have magma that rises. Magma, see the magma there rising to the surface. So the magma rises as magma plumes. Plumes means balls of magma that they rise up because they are heated up by the earth, given energy. So magma plumes rise, and this will then create violent volcanic eruptions. Okay. Violent volcanic eruptions. We need a named example. Hit us up in the chat, guys. Named example of a destructive plate boundary somewhere in the world. Where have you gone? Destructive plate boundary. Where would you give an example? If you get it right, you'll hear the Mario sound. Level up your answers. Okay. Have we got an answer? We'll come back to that in a minute if we have. Right. Haiti. So Callum has put Haiti. Haiti is a bit of a weird one because it has a destructive and it has a conservative boundary. So I'm going to give you a point for that. Mount Vesuvius. Correct. But you are, unfortunately, Callum has beat you to the point, but you are correct. Good man. Sadu, that is a correct answer. Right. The one we're going to go for, though, here is the Pacific Ring of Fire. This is the highest concentration of earthquakes and volcanoes in the world, the Pacific Ring of Fire, the deadliest part of the planet. And the most famous one is the Peru-Chile Trench. It's just off the coast of Peru, off the west coast of Peru. It's called the Peru-Chile Trench. Very famous one. It's the Nazca Plate and the South American Plate that are colliding. Let's put that in there. Oh, the examiner is going to be like, this person knows so much geography. So it's the Nazca Plate and the South American Plate that collide. And yeah, they create huge eruptions. An example of an eruption there was the Nevado del Ruiz eruption. And that happened in 1985. Quite a long time ago, but there's an example of an earthquake and volcanic eruption on that plate boundary. The Peru-Chile Trench. Hey, it's looking good, this. I'm liking it. Kehinde. Kehinde. Right, okay. Let's just change your name then. Here we go. I've heard great things about you, Kehinde. Your geography is really good. Okay. Right. Right, let's do our last one then. It's a conservative plate boundary. Conservative plate boundary. Let's highlight that one. Good. And this is when the plates move side by side. So plates, they kind of slide past each other. Not together, not away, but they would slide past each other. Okay, a bit like so. That's our little diagram. Conservative plate boundaries, side by side. So let's have a quick summary of these ones. If it comes up in the exam, we can explain these. Could be 9 marks, and you could have to do all 3 of these boundaries, possibly. So the plates slide past each other. Okay. Again, we get friction and pressure that builds up. Friction and pressure. Running out of space here, guys. They're often known as a strike-slip fault. So the pressure builds up, and all of a sudden, the plates will slip. And that sudden slip and that jolt releases the energy in the form of seismic waves throughout the tectonic plate. So friction and pressure. And they're often known as a strike-slip fault. Strike-slip fault. When it slips, it's that sudden release of energy, which causes huge amounts of energy in the form of an earthquake. Energy is released from the plates. In fact, we can put that onto our little diagram. There we go. That's our earthquake, and it's kind of radiating outwards. Okay, here we go. As a named example is the San Andreas Fault, very famous fault line on the west coast of the USA. San Andreas Fault. It is the North American Plate and the Pacific Plate. And what's really happening is that the Pacific Plate moves at 6 centimeters per year. So it moves at 6 centimeters per year, whereas the North American Plate only moves at 3 centimeters per year. So because the North American Plate is moving slower, that's why you get the friction built up. And last but not least, you get violent earthquakes. Violent earthquakes. No volcanoes here, just earthquakes. And the most famous one or recent one is probably was the San Francisco earthquake of 1989. Yes, that's probably the most recent one as an example. Mount Fuji is also an example of a conservative plate margin. I'm not so sure about that, actually. I believe that's a destructive boundary, but you could be right. Should we just double check? Let's just do a look. I think that's a destructive boundary, but let me double check with is Mount. Oh no. What type of plate boundary is Mount Fuji? Let's have a little look. Yeah, it's a destructive boundary. I thought it was. Yeah, it's a destructive boundary. As it's the Ring of Fire. It goes around the Pacific Ocean. It's all destructive around there. But yeah, thanks for having a go though and contributing. But yeah, it is a destructive boundary. Okay, look at that. That's our first section done. All about plate boundaries. Well chuffed with that one. Look at that. Okay, let's move on then to looking at the management of hazards. We think this is going to be a big section in 2026, and we're going to use all this section up here for the management of hazards. It's a biggie. Okay, so here's your next question, guys, in the quiz. There are 3 P's of management, hazard management. Governments follow the 3 P's of hazard management. What are the 3 P's? Hit us up in the chat, guys. What are the 3 P's of hazard management? So hazard management is our title for this next section. And we'll finish up on climate change today. So hazard management. I'm going to put a little star here. This is the most critical factor in reducing the impacts of hazards. Countries that get this right, countries that are able to manage hazards effectively, significantly reduce death toll, significantly reduce impacts on the economy, and significantly reduce impacts on the environment. It is a critical factor. Why do more people die in LICs than HICs? It is to do largely with the management of the hazard and the investment they put into hazard management. So I'm going to put here, hazard management is a critical factor on impacts. Yeah, and this can be really argued. Right, who is in for the 3? Oh, Callum. Predict, prepare, and protect. Yeah, predict, prepare, and protect. Yes, planning, not protect. Predict, prepare. Yeah, yours is right. And predict, prepare. Yeah, well done. So Callum is on 2. I'm also going to give Fred 2 because he's also got the question right as well. So the leaders at the moment are Callum on 2 and Fred on 2. Corey, Archie, Finley, Tay, and Kahinde is still on 0. Get yourselves involved, guys. Get yourselves on that scoreboard. So hazard management is absolutely critical when you want to reduce the impacts of a tropical, of any storm, tropical storm, earthquake, volcano. So we're going to put the 3 P's up here. Let's get them in. You've got to know your 3 P's. All governments around the world are following the 3 P's of hazard management. Here we go. So, oops, sorry guys, didn't realize I was screening them. The 3 P's. Put a bit of purple on. So, the first one is we'll do them in order, to predict or prediction. Try to say when the hazard is going to occur, at what time, in what location, at what magnitude or strength. Quite difficult for some hazards. Prediction. Then we can prepare or plan. Prepare is what AQA say. Preparation. Get yourselves ready, organized, and ready for the next hazard event. And then the last one is try to protect yourself from the hazard. Protection. Prediction, preparation, and protection. Which country leads the way in hazard management? Which country, for a positive, for a point on the scoreboard, which country leads the way in hazard management? And that all countries follow. Incorrect by Callum. You're getting a clue now, guys, because I'm drawing the flag. Who is going to be the first one in the chat? Which country leads the way in hazard management? The correct answer is Fred. Well done, Fred. Japan is the correct answer. Yeah, well done. You're on 3. You're beating Callum. Kinde, you can have a point as well. There you go. That's the scoreboard at the moment. Yeah, it is Japan. So Japan lead the way in hazard management. So much so, they have something called the Sendai, which is a place in Japan. The Sendai framework. Let's get that in. Oh my goodness, they're going to be so impressed. The Sendai, just realized it's off the screen. The Sendai framework. This is for global management of hazards. So they've created a document, global management of hazards. So they've created a document that all countries use called the Sendai framework, which outlines how to effectively manage hazards. And it covers prediction, protection, and preparation. Okay, right, let's get straight into this then. We're going to look at earthquakes and volcanoes. So we're going to draw a little table, and we're going to look at prediction, we're going to look at preparation, and we're going to look at protection for each one. So again, we're going to draw a little table. I might need to add a bit to it in a minute. This is why we need the ruler, guys. There we go. Let's do it down the middle here. I do love these revision sheets once they're done. Has everything on one, all the key content on one page. Okay. So earthquake management is going to be our first one. I'm going to get you involved here in the chat. Earthquake management. Okay, and this one we're going to have volcanic management. How we manage volcanoes. Right, let's rule that off there. Oh dear. Hey, what better way to spend a Monday evening in the holidays than talking about hazard management? There we go, look. So, hit us up in the chat. How do we predict earthquakes? What can we use to predict earthquakes? We're going to start with the prediction of that one first. Predict an earthquake, guys. How do we do it? Oh, we're getting fast here. Fred is in. Fred is in. Seismometer is correct. Fred, you're on 4, by the way. Satellite. Not for earthquakes, Kinde. Seismic monitor. Animal behavior. That is worth a point. Yeah, apparently like dogs can sense, certain animals can sense seismic movement before humans. So, Callum, yep, you can have that one. Okay, here we go. Let's have a look at prediction then. I'm just going to zoom you in on this side of the table for earthquake management. So, we can predict earthquakes not very well. There's still a lot of technology and innovation to go on in this area. We cannot predict when the next earthquake is going to be. We can't say what time it's going to happen. We don't even know the magnitude. We are very inconsistent at predicting earthquakes, but we can use some technologies to try to help us. The first one being a seismometer, which was Fred's answer, which is basically a very sensitive instrument that will detect seismic waves. Seismometer. This will detect the movement of the plate once it is moving. So it doesn't give you too much time, does it? But yeah, it does give you some indication of a hazard. Let's go for some geeky ones. The science is there. Let's go for this one. We can predict earthquakes by measuring at plate boundaries radon gas levels. Again, if the radon gas levels are higher at the plate boundaries, that would be an indication that there might be earthquake activity. So radon gas levels is another one. So that's an example. Our seismometers. And the last one we're going to look at is GPS. So what you can do is you can basically put a little signpost, a GPS tag on a plate, and then you can see how it moves. So using geographical positioning system, which is basically you could detect that using any like a smartphone device. You can see if how much that moves. Anything with GPS, kind of pinpoint it on a plate, and then you'll be able to see how much it's moving per year, and that tells you the direction of movement each year, and then you could probably predict from there where it's going. So GPS to track plate movements is a way of predicting. We can also add animals into that one as well, if you wanted to. The most famous organization that tried to predict earthquakes and volcanoes is the United States. Sorry, guys, pencil keeps breaking. The United States Geological Survey, the USGS, are the organization that do this. So it's United States Geological Survey. That's the name of them. Group of scientists that work in the United States monitoring earthquake and volcanic activity, and therefore they release maps and data based on those. Okay, let's think about preparing. Hit us up in the chat, guys. How would you prepare for an earthquake? What could you do to prepare for an earthquake? Oh, something in my cup of tea. I don't know. Preparing for an earthquake. What can you do, guys? Get yourself prepared by doing what? Okay, answers are coming in. Fred, you are now, what a legend, he's on 5. Correct answer, yeah, you could do earthquake drills. What is the name of the earthquake drill that you can do in an earthquake? They teach it in schools in Japan. What is it? What is it? What's the drill called? Can you remember? I'm going to draw the little drill here. That's a table, by the way. And we've got some other answers coming in. So we've got earthquake drill. Let's put that one on. Earthquake drill. It's called drop, cover, and hold. Drop, cover your head, and hold on to the table. Okay, that's some guy under a table there. Look, protecting his head. Yeah, earthquake drills, and he's absolutely right. You can in Japan, they do have National Earthquake Day. Callum, you have got yourself a bonus point, and because you've named a place, let's level up. Here we go. Sound effect. There we go. If you mention a place, you level up your answer, you get a little Mario sound. Yeah, I don't know. Hopefully you can hear that on the live stream. Okay, drop, cover, and hold. Excellent. Right, let's go back to the other answers. We've got evacuation. Yeah, an evacuation plan. Let's maybe draw a suitcase for that. Yeah, because you've got to leave. Evacuation plans. These are so important for earthquakes and volcanoes. Nowhere to go, community centre, sports stadium, somewhere that you can go and contact loved ones if you need to. Yeah, absolutely. Kinde is on with his survival kit. What might you have in a survival kit? Let's put the little survival kit in here. What could be in your survival kit? Who is going to hit us up in the chat? Emergency kit, survival kit. Let's just put that there. What could be in a survival kit? Have we got any answers? Here we go. Food, water, and medicine. Fred, well done. Bandages and water. Callum, yeah. Tin food. You might also have a torch. Yeah, a torch. You're probably going to have a power bank. Yeah, obviously to charge your smartphone up, like your power bank things. You're probably going to have all that stuff ready in a survival kit, ready to go. Right, let's go to the final one, which is protection. What can you do to protect yourself in an earthquake? What do we do in terms of earthquake protection? Just need to make the table slightly bit long, tiny bit longer there. I think I've got holiday brain already, guys. There we go. Well, it is the holidays, and we're doing some geography, so that's good, isn't it? There we go. Right, protection. What can we do in terms of protection? No answers are coming in. Here is, oh, go to open space. That is a good answer. Go to open space is a correct answer. That's probably the best advice if you can. That would help with protecting yourself. Good. What if you can't go to open space? What if you're in a building? Oh, yes. Here we are. Oops. I'm getting so excited. I'm knocking everything off. Kinde, well done. Earthquake resistant structures. So we're going to put that there. Earthquake resistant structures. Resistant structures. Okay. So we're just going to highlight that. It's so important. It's all about building design, building to building regulations, using high quality materials that can resist to some extent earthquakes. So here we go. Next question. Oh, take cover under a table. Yeah, it's called drop, cover, and hold. That's what that's called. Stand under a door frame. Yeah, that does help. You're correct. Absolutely. Here's the next question. Name a feature on an earthquake-resistant building. What makes a building earthquake-resistant? I'm just going to draw a quick earthquake-resistant building here. There we go. Some special features there. Okay, well done. Kinde is catching up. Fred, you need to be worried. Window shutters is correct. Automatic window shutters to prevent the glass from falling in or out of the building, causing injury or harm. Concreted to the bedrock is correct. Yeah, solid foundations connected to the bedrock is correct. Oh, Fred, you're in trouble here. Tay, automatic window shutters, I will give you that, even though somebody else has said that. That is correct. Shatter-resistant glass. Never heard of that. Might be. Fire-resistant would be one. Let's put that on. Fire-resistant materials. So they tend to be made of fire-resistant materials in case, obviously, of a gas leak and electrical failure. Fire-resistant. They tend to have a flexible steel structure. So they have flexible steel structure on the outside, so the building can move and sway with the seismic activity. What else we got? We've got base isolators. So these shock absorbers at the base here that will absorb the seismic waves, base isolators. So they absorb the seismic waves, which then protect the building above. And like my little diagram here, a triangular shape with a lower center of gravity, which makes it more sturdy and stable. You could have also had window shutters to protect an open space for evacuation would have also helped. Named example is Taipei 101, a very famous building in Taiwan, which is earthquake resistant. Taipei 101, very iconic building. Right, there is all our goodies of how to predict, prepare, and protect from earthquakes. Let's move on to our volcanoes. Here we go. Volcanoes. So here we go. How do we predict volcanic activity? What do we do to predict our volcanic activity? Any ideas? Hit us up in the chat, guys. How do we predict volcano or volcanic eruptions? What can we do? Other than seismometers, we've already used seismometers. They're very good at predicting. We are quite good at predicting volcanic eruptions. We're much more accurate at predicting when and where volcanoes are going to erupt. So we've got much better preparation there. So we have satellite imagery. I'm going to accept that. Thermal imagery is what we use. Kahinde is on 5. Oh my God. Fred's dropping out of it here. He's got 6. Callum's on 6. Yeah. So predict. We can use satellite thermal imaging. So heat thermal imaging cameras. Obviously, it will glow a whiter color when the heat is near the surface of the volcano. It will glow whiter, so you can see where the hot patches are on the volcano. You are correct, Callum. Gas is the correct. Let's get that one on. We can measure sulfur dioxide levels. We can measure sulfur dioxide gas. Which is using a gas measurer, gasometer measure type device, which will measure sulfur dioxide levels. They do this in Mount Etna in Italy. They've used equipment like that, Mount Etna, to measure to measure sulfur dioxide. Last one we're going to go for. In fact, we'll go for 2 more. 2 more. Let's go 4. We can measure surface water temperatures. Yeah. So water that's hot. Oh, sorry guys, just knocked the camera. Oh dear. There we go. We're back. So hot water's heated by the magma underneath. Yeah. Here's our magma underneath the surface of the rock. That will warm the water up and create steam. Yeah. And we can measure that water temperature so we can see if the volcano is active. Surface water temperature creates our hot springs and also our geysers, which are eruptions of water. Last but not least, we've got our tilt meter, which also measures the angle at which the volcano is tilting. And as the volcano kind of expands with magma inside, it causes the flanks of the volcano to tilt. And we use a tilt meter to measure the change in angle on the flanks of the volcano. Yeah, it kind of swells and it changes shape. The tilt meter detects a change in shape of the volcano. Change in shape. Yep. Of the volcano. In terms of preparation, we can do all of the following: survival kits and evacuation plans. So we're going to leave those there. We can also prepare by having wait a minute. Prepare by having protection zones. In fact, we'll just have evacuation plans. There we go. Evacuation plans on there. Reoccurrence example, like if an earthquake. Oh yeah, reoccurrence intervals. That's a really good one. Kahinde. Yeah, well done. Reoccurrence intervals. We can put that one on there as well. Right, last but not least, we can protect from volcanic eruptions by, let's have a little look. Protection, we can have lava diversion channels. There we go. Where you divert the lava away from communities and businesses and divert it to an area that is away from any infrastructure and dangerous areas. So we've got our lava diversion channels. There we go. That moves the lava away from urban areas and moves it into rural areas where there's less of an issue. They've done this again in Mount Etna in Sicily, and that was in 1983, diversion channels. You can also have exclusion zones. So don't build in this area of the volcano to protect people. Exclusion zones, which is all part of it. The last thing you can do is you could spray water onto lava flows as well to cool them down. They did this in Iceland, in Jaime, in the 1980s. They spray water onto the advancing lava flow to cool it down and solidify it. Okay, that's our management of hazards. Look at that. I'm well pleased with that. Look at that. That looks awesome. So that is everything in terms of earthquake and volcanic hazard management. We are much better at managing volcanoes than we are managing earthquakes, but all of these things help to save lives and protect communities. Right, so we're going to go on to the causes of climate change. We've got this last section down here, which is going to be for the causes and management of climate change. So let's go for this. Causes of climate change. We're going to look at natural causes and human causes of climate change. Causes of climate change. Here we go. It's looking good. I hope your revision notes are looking super nice as well. Here we go then. Let's start with natural causes of climate change. These are the natural ones. These occur naturally without any interference of human activity. So what are the three natural causes of climate change? Let's zoom in. Hit us up in the chat, guys. Oh, Tay was very quick there. He knows this well. The Milankovitch cycles. Yes. Tay is on a comeback. He has got 3. Let's up the scores. Callum is on 7. Fred is on 6. Tay is on 3. And Kahinde is on 6. Yes. Fred. Volcanic activity. Well done. And Tay is... sunspots. Okay. Sunspot theory. Well done, guys. They are the 3 natural causes of climate change. So let's zoom in. Okay, let's get these down then. So the first one is going to be the Milankovitch cycles. Milankovitch cycles. He was a geophysicist, and he looked at how the Earth's orbit changes in space. And basically, when the Earth moves further from the sun, the Earth gets cooler, and when the Earth moves nearer to the sun, it gets hotter or warmer. So he studied these cycles called the Milankovitch cycles. So the first one, I'm just going to use S for the sun, and we're just going to put the first one on. Where is the orbit of the Earth? The Earth is going to be our blue dot. the orbit of the Earth changes from a circular orbit, which it normally is. So it is normally, it's normally a circular orbit like so. Yeah. But every 100,000 years, the orbit changes shape. Orbit changes shape every 100,000 years. And because it changes to this elliptical or egg-shaped orbit, it makes the Earth cooler. This is called, for my geeky geographers that are tuning in, this is called eccentricity, when the orbit changes shape to this elliptical orbit. Right, our next one is the tilt of the Earth. Again, when the Earth tilt changes. So the Earth's orbital tilt can change between 24.5 degrees and 21 degrees. So if it tilts nearer to the sun, we will be warmer, and if it tilts further away from the sun, we will be cooler. It's all about distance from the sun. So this one is about tilt changes, and this one is called obliquity. Obliquity. And this happens every 41,000 years. The Earth in space changes its tilt or its angle, making us warmer or colder. So that is obliquity. Let's put that. So we've got the tilt changes. Let's just highlight tilt. The orbit changes. And then our last one is, for natural Milankovitch cycles, it's the wobble. So the Earth wobbles in space. Because the Earth is not a perfect ball or sphere, it's a geoid. It wobbles on its axis, okay? If it wobbles nearer to the sun, we get warmer. And if it wobbles further away, we get colder. This is called precession for those grade 7 and above. This happens every 26,000 years. The Earth wobbles on its axis in space, making the distance either nearer or further away from the sun, naturally changing the climate. Right, let's have a little look at two others. We've got our volcanic theory. So these are different to the Milankovitch. We've got volcanic theory, which is when volcanoes erupt huge amounts of volcanic ash. So let's just put the volcanic ash there. Here is our Earth, and here is our sun. Just as a named example, this happened in Krakatoa, 1983, where the mega eruption of 1883, blocked out the sun and caused global temperatures to be reduced by 1 degree. So volcanic ash blocks out the sun, cooling the Earth. Cooling the temperatures on Earth, it blocks out the solar radiation, as you can see by our little diagram there. Yep. There we go. The volcanic ash blocks it out. So you've got there Mount Krakatoa. Mount Krakatoa, 1883. The year without a summer is an example of volcanic theory. Last but not least, let me just highlight these. Milankovitch cycle, volcanic theory, and sunspot theory. This is to do with the amount of solar radiation. So here is our sunspot theory. There we go. Okay, so this is quite a simple theory. The more spots on the sun, let's just get our spots on the sun. So scientists can look at the sun through kind of specialized glasses. Each spot represents a solar flare moving towards Earth. And the more spots, the more solar radiation leaving the sun, the more flares leaving the sun. And therefore, the warmer the Earth. And that is as simple as the theory gets. The more sunspots, the warmer the Earth is, Earth's temperature. Okay, that's how that one is linked to it. So there we go. That's our sunspot theory, often linked to warmer periods in our history, such as the medieval warm period, could be attributed to sunspot theory. Okay, over on this side, let's go over here. Let's have a look at human causes of climate change. Right, we're over here. So human causes, how people cause climate change. All right, human causes. Wow, it's looking super good, this revision is, guys. This is linked to the enhanced greenhouse effect. The enhanced greenhouse effect. Without the enhanced greenhouse effect, we would be minus 18 degrees on average. So the greenhouse effect actually maintains Earth as a habitable temperature. It maintains life on Earth. So now we're going to draw the greenhouse effect diagram. Let's get the Earth on. Let's just put the Earth here. I do quite like drawing all these little clip art pictures. Here we go. There's our Earth. Okay, let's hit us up in the chat then, guys. Can you name a greenhouse gas? Can you name a greenhouse gas? Let's get our sun on. Okay, vote now. We are getting close to our Kahoot quiz as well to finish off tonight's spectacular. Let's have a little look who is in and get closer or further from the sun. Yeah, you're right. Okay, Callum, CO2, greenhouse gas, main one, carbon dioxide. Fred, someone's beat you to that one. Kinde, methane. Kinde, water vapor. Well done. We've had methane, CO2. There is another greenhouse gas, guys. Who's going to get that point for our next greenhouse gas? What is it? Okay, we're going to put our greenhouse gases in here. Right. The answer to that one is nitrous oxide is our fourth greenhouse gas. So you've got CO2, methane, nitrous oxide, and water vapor is classed as a greenhouse gas. It does trap heat inside the atmosphere. Okay, what activities release greenhouse gas? What human-induced activities causes greenhouse gases to be released? Can you name any? Right, hit us up in the chat, guys. Deforestation is correct. Slash and burn. So when you cut the trees down and then you burn them to clear the land and clear the stumps, yeah, is a cause of deforestation. Is a cause of greenhouse gases. Deforestation. There we go. Deforestation releases carbon dioxide. So deforestation. Which others? Yeah, transport. Let's put transport on. So cars, vans, lorries. Yeah, they release. So we're basically saying transport. They release nitrous oxide, which is a greenhouse gas. So transport vehicles release nitrous oxide. Yeah, this is our greenhouse gas layer in the atmosphere. Greenhouse gases. There we go. Let's go for industry, burning coal, oil, and gas, fossil fuels, coal, oil, gas, industry releases our CO2 as well. And last but not least, I might have to make my word a little bit longer here. Farming. There's my little farm animal. And that's a little rubbish dump of waste. So waste, landfill sites, rubbish dumps, also agriculture. They release a greenhouse gas called methane. Yeah. Rice farming releases methane, which is our, let me just put it on here. Methane. It's released by things like landfill sites, rice farming, paddy fields, and beef cattle, which are on there as well. Production of limestone, rearing of cows, growing of rice. Yeah, you are right, Tay. You're coming back here, Tay. You're almost, look, you're on 5. Callum's on 8. Fred's on 7. Kinde is on 8. So this is how it works. Shortwave solar radiation comes into the atmosphere. It doesn't get blocked by the greenhouse gases. So it's called shortwave radiation. Enters the Earth's atmosphere. It's known as UV or ultraviolet light. That can pass through all of the greenhouse gas layers and enters the atmosphere. Shortwave solar radiation. And then that's our orange arrows. They're shortwave solar radiation. And then the radiation is reflected as long wave infrared radiation. Infrared radiation. Which is the reason why some of the heat gets trapped. So if we put that onto our diagram here, the long wave gets trapped inside, this is our red arrow, between the Earth and the lower atmosphere. Yeah, because it's infrared long wave, it can't pass through that layer of greenhouse gases of CO2, nitrous oxide, and methane. So it gets trapped. So enters as shortwave, reflected back off the Earth as infrared long-wave radiation, trapped by the greenhouse gases, increasing global temperatures. At the moment, global temperatures have increased by 0.8 degrees since the start of the Industrial Revolution. 0.8 degrees, almost 1 degree rise in global temperatures since the Industrial Revolution. It's not looking good. It's not good, and it's set to rise even more. The IPCC, the Intergovernmental Panel for Climate Change, predicts that global climate temperatures will rise to anywhere between 3 to 6 degrees. A 6-degree rise in global temperature is catastrophic for us. We do not want it. Right, we're going to go on to our last little section, as you can see here. Wow, look at that, guys. Look at that. That is phenomenal. All on one page. All the key revision, apart from our case studies, which we'll do next week. All on one page. I'm absolutely loving it. Thanks for joining us this evening on our live stream. We are going to do our Kahoot in around about 5 minutes time. So stay tuned for that. Hopefully you can win our interactive Kahoot quiz. It's a first for this year as well. Right, here we go then. Managing climate change. I've got a big feeling about this. Last time it was on the paper, it was done not so well by the geographers around the country, and the exam board have hinted to some extent that this is an area that we need to get better at teaching. So we're going to look at ways in which we can mitigate climate change, and we can also adapt to climate change. So mitigation, keyword. Let's just zoom you in so you can see. Mitigation. There we go. Let's highlight that. So you can either mitigate or adapt to climate change. Mitigation is about tackling the causes of climate change. Yeah. So in essence, it means to reduce greenhouse gases. So how do we reduce the greenhouse gases? That's essentially what mitigation is. So hit us up in the chat, guys. How can we reduce greenhouse gases? What are the ways we can do to reduce greenhouse gases? Hit us up in the chat, guys. I'm just going to have a little drink of water. What can we do to reduce greenhouse gases? Okay. Have we got any answers? Okay, let's get cracking then. Our first one, according to the IPCC, the Intergovernmental Panel for Climate Change, the best way to tackle greenhouse gases is to plant trees, is the answer. Plant trees. These things are incredible. They help to tackle climate change. Plant trees. Also known as afforestation. Afforestation, planting trees, because you can modify, you can enhance photosynthesis, whereby we can absorb water, CO2, and solar radiation, and we can take that CO2 out of the atmosphere as part of photosynthesis, which is brilliant. Okay, the other one is we can use more renewable energies. So renewable energy, instead of using coal, oil, and gas, we can use renewable energies. So, for example, in the UK, the development of wind energy, offshore and onshore wind, big push on that in the UK. We can use. Oh, still some answers coming in here. Fred, carbon capture and storage. Good man. You are all on 8. Just to let you know, Callum's on 8, Fred's on 8, Kinde is on 8 as well. Well done. Carbon capture and storage. This is a really big one. So this is when we capture CO2 from the atmosphere. It's absorbed in the atmosphere. It's then converted into a liquid and buried in the ground, back in the geological storage. So we capture CO2 from the atmosphere, it's converted into a liquid, and then it's stored back into, it's stored back into the rocks underneath the ground in liquid form. It's called carbon capture and storage. It's probably the best one to talk about, really. Carbon capture and storage, or CCS. The country that does a lot of this is Norway. Norway leads the way, or one of the countries that lead the way. So the US also have a lot of CCS, carbon capture and storage technologies. It's very expensive. It's very costly. We don't fully know the impacts of the technology either, because it's new, it's innovative, and it's expensive. But it could be the answer, getting that carbon dioxide back into geological storage, back into the ground. Right, one of the main ones which would impress the examiner is international agreements, signing agreements, targets, setting targets. So international agreement, getting world leaders together to sign on targets for cutting emissions. The most famous example is Paris, the Paris Conference of 2015, where countries set targets to limit global temperature rise to 2 degrees maximum. That is a critical statistic. So they signed up to reduce their emissions so that the global temperature does not rise more than 2 degrees. That was the most iconic international agreement, Paris 2015, that we've ever had. Right, last but not least, how do we adapt? So adaptation of climate change. Adaptation is about, let's just move that across. Here we go, guys. We're in adaptation. So adaptation is about reducing or tackling the impacts, not the causes, tackling or reducing the impacts. This is often more expensive. They say if you spend £1 on mitigating, you save in the future £10 on trying to adapt to climate change. So hit us up in the chat, guys. This is the last set of questions before we start our Kahoot. What can we do to adapt to a warming climate? What can we do to adapt to a warming climate? I'm just going to bring that down there. So adaptation, what can we do to adapt? Answers are coming in. Eat a plant-based diet is a correct answer, because we know that cattle, in particular cows, release methane. So yeah, a plant-based diet potentially, that'd be, wait a minute, that would be more mitigation though, isn't it? Yeah, you're reducing the causes there. So that's mitigation. Adaptation, what can we do to live with climate change? So here we go. We can try to, because the world is going to be a warmer place and there's going to be less water, we can conserve water. Use water meters. We could use something called drip irrigation on farmlands. Drip irrigation would help to reduce how much water we use. More crop per drop is the phrase for drip irrigation. We can accept that the climate is going to get warmer, and we could have more floodplain zoning or coastal zoning. So because we know sea levels are going to rise, because we know rivers are going to flood more, especially in places like Burton-upon-Trent, we do not build close to the river. So we could have flood plain zoning, which is basically to limit development in areas that are close to the river and rising sea levels, which then leads me to the last one. We could also have sea defences. Building sea defences, which obviously helps to protect against a rising sea level. Global sea levels are predicted to rise by 1 meter in total by 2100. So we could build new seawalls. We could build more sea defences. I've run out of space, guys, there, but we have finished our revision. We could also add to that genetically modified crops. We could modify our crops to survive in drier, warmer conditions, which would also help massively. Right, have a look at that, guys. Wow. Wow, wow, wow. That looks awesome, doesn't it? Really, really impressed with today's revision. All on one page. All the key things that you need for natural hazards in 2026. We're going to do our case studies next week. Check out the video, hit the subscribe and the notification bell as well, and we can get involved in that one. In terms of our quiz, our winner is, we don't have a winner. We've got Callum on 8. We have Fred on 8. We have Kahinde on 8 as well. Well done, guys. Hit that like button for me so that it gets pushed out to other people who are also studying geography. Right, I'm going to go back to our Kahoot quiz. So hopefully we've got enough battery power to get on our Kahoot. Let's just get rid of that one and then add to stage. Remove that one. I want to add another one to stage, hopefully. Let's just remove that all together. Remove. Stop screen. Okay, let's try here. Is this going to work before my battery goes on my laptop? Hopefully it does. If not, I will see you next week as well. Hopefully on here. Right, let's go. Quick quiz. We might have to reduce the sound, I think. Switch the microphones. Right, here we go. Continue with no island. We need to get some charging. My laptop's going to switch off here. Right, are we on? Start. I'm also just going to switch the microphone, guys, as well, just for this last little bit. Here we go. Can you hear the sound? Hopefully the sound is back now, guys. You are not on. You're on the webcam sound, so the sound might sound a little bit different. Can you hear me? Just give me a thumbs up in the chat, guys, if you can still hear the live stream. Hopefully you can. Right. Are we on? Right, let me get the code up for you guys. Remove. Right, stop screen. This is the first ever time we've done a live stream Kahoot. So I think it is this one here, guys. All right, there you go. Right, jump on, guys. Jump on the quiz. So it's all based on tonight's it's on our revision for natural hazards. Jump in. Have we got any players? Hopefully we've got some players on. Just enter the code. You need to download the Kahoot app on your phone or your mobile device, and then you can join in tonight's quiz. Yes, it's working. Yes, nice one, guys. A bit pioneering here. So we've got Tay, we've got Fred. Are we waiting for any more players? Jump on, jump on. All based on tonight's natural hazards revision. Hopefully you've enjoyed yourself. Right, we're going to get started, guys. Here we go. Eyes down and look in. It is live. Right. Okay. So it's about getting the correct answer and also the fastest answer. If you do join in, you can still jump on right now. Which shape of plate margin involves two plates sliding past one another? Okay, vote now. 3. Correct. Well done. Question 2. Which hazard is found at a conservative plate margin? If you still want to join, the game pin is at the bottom of your screen. You can join in at any time. Correct answer is earthquakes only. Ooh, it's close. Number 3. In the 3 Ps, what does protection refer to? Protection. Yes, earthquake resistant structures. You two are very good at this. Number 4. Which of these is an example of prediction for volcanic eruptions? Predicting volcanic eruptions. We're just waiting on, yes, 100%. Just see how well this revision is working, look. You know your stuff, guys. Well done. Which of the following is a natural cause of climate change? Hope you've enjoyed tonight's live stream. We will be back next week for another live stream on natural hazards case studies. You can also, yes, Milankovic cycles. You can also watch on catch up or listen to it like a podcast if you wish. How do large volcanic eruptions temporarily cool the earth? Yes. Ooh. Yeah. Only one answer there, and it was incorrect. So no changes in the leaderboard. Which greenhouse gas is associated with cattle farming and rice paddies? I reckon there's going to be quick answers here. It looks like one of our quiz people have dropped out. Has one dropped out? I don't know. Hopefully not. Oh, no, it's still there. Methane. Well done. That's good. I was worried that someone dropped out. Which strategy is an example of climate change mitigation? Climate change mitigation. Even if you're not playing live, you can obviously have a little go at the quiz as a bit of revision at the end of the live stream as well. It's good. Everybody can join in and have the fun. A split answer, and only one person got it right. So who was that? That was Freddie. Come on, Tay. Which strategy is an example of adaptation? Adapting. Which one of these is about adaptation? You need to get it back, Tay. Let's get this one back. Oh, yes. Another split decision. The correct answer is, the other three are mitigation. Oh, no. Freddie's running away with it now. I was hoping that was you, Tay. Why is mitigation different to adaptation? Answers coming in. Oh, correct. 1 and 2, red and blue were both right. We're nearly there, guys. Which orbital cycle describes the Earth's orbit changing shape from circular to elliptical? Wow, this is hard. Orbital changing shape from circular to elliptical. Answers coming in. Oh, well done, guys. Wow, that is smart. Eccentricity, well done. Let's go 12. What piece of evidence shows us climate change from thousands of years ago? What can you use to tell us about past climates from thousands of years ago? This one wasn't covered directly in today's live stream. Ice cores is the correct answer. Oh, it's Fred. He's not got one wrong yet. How does carbon capture and storage help to mitigate climate change? Let's have a little look. Who knows this one? Correct. Well done. The scores are really good, guys. 2 to go. Planting trees or afforestation is a mitigation strategy because... Okay, that was quite an easy one, wasn't it? The answer's there. We're making it quite easy. Right, last question. What is the main goal of the international agreement set out by Paris in 2015 to limit the global temperature by how many degrees? And waiting on one answer, guys. Correct. Limit it by 2 degrees. You guys have been absolutely awesome today. You've smashed the live stream. You've done an amazing bit of revision. Wow, look at that. And the winner is Tay in second. And the champion is Fred. If you want to be the champion next week, join the live stream. We'll have a coup at the end as well. We're going to do Haiti earthquake, and we're also going to look at Typhoon Haiyan. Hit the like button, hit the subscribe button. Thank you so much for joining us today. Hope you've enjoyed yourself. And yeah, I will see you on the next one in a week's time. Thank you very much, guys. Good night. Oh, dear. Well done.